Hi there, welcome back to Best Practices for 4th grade. And today we're going to talk about adding and subtracting fractions and mixed numbers. I'm Bailey. So before we start our work with talking about add and subtract fractions and mixed numbers in 4th grade, I want you to take a minute and I want you to think about this problem right here. I have 2/3 plus 4/3. So we're going to take a minute and we're going to look at two different student answers and think about which one is correct and why is that answer correct. So the first one is Dynamite. Dynamite thinks the answer is 6/6 or 1 whole, and he says that it's because you add both the numerators and the denominators. Hollywood says the answer is 6/3 or 2 wholes because the numerator gets added and the size stays the same. So when we're thinking about what this might look like in the classroom, we know that Hollywood is correct because the denominators don't change. The size of the piece that we're adding stays the same. It is important to note that Dynamite does have some good fractional knowledge. He understands that 6/6 is the same as 1 whole, but he'll need some practice and some strategies to think about why the denominators stay the same size. And we're going to talk about some of those strategies to help that misconception in this video. This unit for 4th grade has two main key learning. The first one is that students should be able to add and subtract fractions with like denominators using tools, drawings, number lines, and the properties of operation. This will include fractions greater than 1 and mixed numbers. The second key learning is that students should be able to solve real-world problems involving addition and subtraction of fractions with like denominators, again, using those same strategies that they talked about in the first learning. What does student learning look like in the classroom? During this unit, students should have many opportunities to explore adding and subtracting fractions with like denominators, including fractions greater than 1 and mixed numbers. Students will start by representing a fraction in multiple ways, bringing back the strategies they used to compose and decompose fractions earlier in the year. Students can use concrete tools, representations, and equations to show how they compose and decompose the fractions. Throughout the unit, students should be exposed to real-world problems and given time to model using concrete tools, using like fraction tiles or even pattern blocks. Then they should be given time to turn that representation into a drawing, a number line, or even an equation. And we want to make sure that students really work and compare the two models and see how they're alike and different when we're adding versus subtracting fractions. Throughout the entire unit, it is critical that we're using concrete tools and representations to help students understand that when we add fractions with like denominators, the denominator or the size of the piece is staying the same, and the thing that's being changed is the numerator or the number of pieces. So throughout this unit, the MTRs are 2 and 7. What does student learning sound like in the classroom? If we were to ask students, can you subtract denominators and ask them to explain, we would expect them to explain that the denominator tells the size of the piece and that doesn't change when we're adding or subtracting fractions. What part of the model represents the difference? When students draw a model of subtracting fraction, the total amount needs to be drawn and then the pieces should be crossed off to represent what was taken away. The pieces that are left over represent the difference. So what does this mean about the improper fraction, 5/3, and the mixed numbers, 1 and 2/3? Students should be able to show that these are the same amount, and they could show this using a model, a representation, or an equation. The last question could be, how could you solve each subtraction scenario without a model? This question is really targeted at moving students away from that representational stage into the abstract, thinking about the properties of operations and using equations. The MTRs throughout these questions are 1, 4, and 6. Throughout any math unit, students need to use precise math vocabulary. Throughout this unit, some of the words that we should hear are denominator, difference, fraction, improper fraction, or fraction greater than 1, mixed number, or sum. Students should be able to use these words while they're describing their mathematical ideas. How will students demonstrate their knowledge? Students can demonstrate their understanding of adding and subtracting fractions with like denominators, including mixed numbers, using concrete tools, drawings and models, and equations. Students will be given multiple real-world situations and will be asked to solve using a model. They'll also be asked to write an equation and a solution statement that goes with their real-world situation. Playing games is a really easy way for students to demonstrate their learning. In this particular game, students are playing Connect 4. They're given a real-world question, asked to solve it, and when they get it correct, they get to place a count. The person with the first 4 in a row is the winner of the game. The MTRs demonstrated throughout this is 1, 2, 4, and 7. Here are some questions we can ask to gauge student understanding. First question, how can you decompose 4/3 into a sum of fractions in more than one way? So students should be able to decompose this in multiple ways. And if you look at your screen, you'll see a couple of equations that represent 4/3. Explain how to find the difference between 2 and 1/4 minus 1 and 2/4 using visual models. Students can use concrete tools or drawings to subtract the two fractions and explain that regrouping is needed. So if you look at the first fraction, it's 2 and 1/4, and I subtract 1 and 2/4. So I could subtract 2 minus 1, but I'm going to have some problems when I try to take 2/4 away from 1/4. When you add two fractions with the same denominator, why does the sum also have the same denominator? Students should be able to explain that the size of the piece does not change when you add them. The MTRs demonstrated in these questions are 2, 4, and 7. Here are the tasks students can do at home to practice their skills. Find a favorite recipe and add some of the like denominator fractions. So an example I have on the slide is a rolled sugar cookies recipe. I could ask a student to add the vanilla, all-purpose flour, and salt because they all have the same denominator of a half. Students can then draw a model and determine the sum. The MTRs for this activity are 1 and 7. Remember, we need to give students many opportunities with tools to understand that the denominator or the size of the piece stays the same when we are adding or subtracting like fractions. Thanks for joining us today during Best Practices for Grade 4 Add and Subtract Fractions and Mixed Numbers. See you again soon.